welcome to this channel. In this video we're going to be looking at the question you can see on the screen. The limit as of x of 2 minus x over x squared plus 3x minus 10 as x tends towards 2 from the right. That's what the 2 plus implies. So how do we tackle this? We first of all analyze the function by substituting 2 directly, and if you substitute 2, that implies 2 minus 2 over 2 squared plus 3 into 2 negative 10, and that's 2 negative 2, which is 0 over 2 squared, that's 4, plus 3 times 2, that's 6, negative 10, and that's 0 over 4 plus 6, that's 10, negative 10, that's 0 over 0, which is an indeterminate form. And if we have indeterminate forms, we have two options. Is that to use the factorization of the expression given, or we use L'Hopital's rule, which is the direct differentials of the numerators and denominators as we have in this case. So what we simply do, if you should carry out the factorization, we look at the denominator, and then we have x squared plus 3x negative 10, and we can look for two numbers we could add together. That's going to give us 3x, and we're going to multiply. That's going to give us negative 10x squared, right? So those two numbers, if you look at factors of 10, we have 1 and 10, we have 2 and 5, we have what again? Yeah, so those are two factors, 2, 5, and 10. 1, 2, 5, and 10 are the factors of 10, right? So we could now bring that together and say we could derive 3 by saying 5x negative 2x, because we're looking for a product that gives us negative 10, right? And 5x negative 2x is actually 3x, right? That's x squared plus 5x minus 2x, negative 10. Then if we factorize this as x into x plus 5, negative, we then take out 2 since 2 is common to 2x and negative 10. So that's negative 2 into that, that's negative 2x divided by negative 2, that leaves us x, and then negative 10 divided by negative 2, that's the positive 5, right? So bringing everything together, we have x negative 2 into x plus 5, right? So that's for the factorization of the denominator. So then we then have limit as x tends to 2 plus that's limit as x tends to 2 from the right to negative x over x negative 2 into x plus 5. And we could see that we could rewrite 2 negative x as negative into x negative 2, right? That's like a swap. There's a change in sign there. So that it would then conform to what we have in the denominator, right? Because if we open this, that's going to give us negative x. Negative is positive. That's negative x plus 2, which is 2 negative x, right? So that's what we have over x negative 2 into x plus 5. And this cancels this, and we're left with negative 1 over x plus 5. I hope you get what we did. I hope we understood what I did over there, right? We saw that we have 2 negative x and we have x negative 2, right? Just like if you have 5 negative x, you could use write as negative x plus 5, right? That's like a kind of like a factorization. So then the limit could then be rewritten as x tends to 2 from the right of negative 1 over x plus 5, and that will be equal to negative 1 over 2 plus 5. That's by substituting 2 where we have x, and that's negative 1 over 2 plus 5, which is negative 1 over 7. So that's the limit as the function tends to 2 from the right. And the main stuff behind this is that we first of all substituted 2 into the function, and at the end of the day we had 0 over 0, which is an indeterminate form, right? And if we have an indeterminate form, there are two things that we could deduce from that. One is that the function is undefined at that point, right? And in this case the point was 2, right? X was then into 2, right, from the right. And then the second is that the limit at c, which in this case was 2, is possible, right? The limit at c equals 2 exists, right? So when we have an indeterminate form, the limit at c exists, but the function at that particular point is undefined. So that's how we were now able to now use this, the theorem that says that for a limit to exist, the limit as x tends towards c from the right is equal to the limit as x tends towards c from the left, and that's still equal to the limit as x tends towards c, right? So if the limit exists, the direction from which x approaches c doesn't matter. Whether it approaches from the left or from the right, we're still having the same result. So do you get? So that's how we evaluated that. Thank you so much for watching the video to this point, and I encourage you, please do well to subscribe to this channel by clicking the subscribe button, like and share this video, and I hope that more videos to come you would also do well by watching those ones. Thanks you so much for watching, and have a nice day.